I drive through the countryside of southwestern Ontario in Canada, video recording those drives, most of which I take in the evening. And then I add soothing music and narration to those videos, much like what you're listening to now. And furthermore, the narration to those videos is completely and entirely generated by the AI ChatGPT. I asked the AI ChatGPT, what are the top 10 mathematical problems that have yet to be solved, and give a 100-word description of each problem. And this is what it generated. First, it began with a preamble. It said, here are the top 10 mathematical problems that have yet to be solved, along with brief descriptions of each problem. Number 1, Riemann hypothesis. This problem, first proposed by the mathematician Bernard Riemann in the 19th century, concerns the distribution of prime numbers. It states that all non-trivial zeros of the Riemann zeta function, a function that encodes the distribution of prime numbers, lie on a specific line in the complex plane. A solution to this problem would have significant implications for number theory and the distribution of prime numbers. Number 2, Poincaré conjecture. This problem, proposed by mathematician Henri Poincaré in the early 20th century, concerns the topological structure of three-dimensional manifolds, shapes that can be stretched and bent but not torn or punctured. It states that every simply connected, closed three-manifold is topologically equivalent to the three-sphere, a sphere with 4 dimensions. A solution to this problem would have significant implications for topology and geometry. Number 3, Birch-Swinnerton-Dyer conjecture. This problem, proposed by mathematicians Brian Birch and Peter Swinnerton-Dyer in the 1960s, concerns the behavior of elliptic curves, curves that can be described as the set of solutions to a specific type of algebraic equation. It states that the rank of the group of points on an elliptic curve over the rational numbers is related to the behavior of the curve at specific points. A solution to this problem would have significant implications for number theory and algebraic geometry. Number 4, Hodge conjecture. This problem, proposed by mathematician W.V.D. Hodge in the 1950s, concerns the topological structure of algebraic varieties, geometric objects that can be described using algebraic equations. It states that the Hodge decomposition of the cohomology group of a compact Kähler manifold, a type of smooth manifold with a specific type of geometric structure, is unique. A solution to this problem would have significant implications for algebraic geometry and topology. Number 5. Navier-Stokes existence and smoothness. This problem, first studied by mathematicians Claude Louis Navier and George Gabriel Stokes in the 19th century, concerns the behavior of fluid flow. It asks whether solutions to the Navier-Stokes equations, a set of differential equations that describe the motion of fluids, always exist and are smooth, without sharp corners or breaks, for a given set of initial conditions. A solution to this problem would have significant implications for fluid mechanics and the study of fluid flow. Number 6. P versus NP. This problem, first proposed by mathematician Stephen Cook in the 1970s, concerns the relationship between two classes of computational problems: those that can be solved quickly by a computer, P, and those that can be verified quickly by a computer once a solution is provided, NP. It asks whether every problem in the NP class can also be solved quickly by a computer. A solution to this problem would have significant implications for computer science and the study of algorithms. Number 7. Yang-Mills existence and mass gap. This problem, first studied by mathematicians Chen-Ning Yang and Robert Mills in the 1950s, concerns the behavior of subatomic particles and the fundamental forces that govern them. It asks whether solutions to the Yang-Mills equations, a set of differential equations that describe the behavior of these particles and forces, always exist, and whether there is a mass gap, a minimum amount of energy required to create a particle for a given set of initial conditions. A solution to this problem would have significant implications for particle physics. Number 8. Collat's conjecture. This problem, first proposed by mathematician Lothar Collatz in the 1930s, concerns the behavior of a specific type of iterative process known as the Collatz function. It states that for any positive integer, repeatedly applying the Collatz function will eventually result in the number 1. A solution to this problem would have significant implications for the study of iterative processes and the behavior of simple mathematical systems. Number 9. Goldbach conjecture. This problem, first proposed by the mathematician Christian Goldbach in the 18th century, concerns the distribution of prime numbers. It states that every even integer greater than 2 can be written as the sum of 2 prime numbers. A solution to this problem would have significant implications for number theory and the study of prime numbers. Number 10. Beal conjecture. This problem, proposed by mathematician Andrew Beal in the 1990s, concerns the behavior of numbers and their prime factorization. It states that if a to the x plus b to the y equals c to the z, where a, b, c, x, y, and z are positive integers, and x, y, and z are greater than 2, then a, b, and c must have a common prime factor. A solution to this problem would have significant implications for number theory and the study of prime numbers. After generating the list of the top 10 mathematical problems that have yet to be solved, the AI ChatGPT added a coda. It said, "It's worth noting that these are just a few of the many unsolved mathematical problems that have been proposed over the years. Many of these problems are extremely difficult and have eluded solution for decades or even centuries. Solving these problems would likely require significant advances in mathematics and could have important implications for a wide range of fields." That was the AI ChatGPT's response to the question, what are the top 10 mathematical problems that have yet to be solved, and give a 100-word description of each problem. And now, for those who wish to continue driving through the rural countryside of southwestern Ontario, enjoy the next few minutes.